This is a brief tutorial on circuit, series, and parallel, and we'll work in some Ohm's law. In this case, we've got a circuit in series. We've got 28 ohms of resistance on the circuit. We've got a 2 ohm resistance. That's the internal resistance of the battery, which we'll consider that to be in series. So what's the total resistance of the battery? For a series circuit, the resistance in series is going to be resistance 1 plus resistance 2. So it'll be the 28 ohms plus the 2 ohm internal resistance for a total of 30 ohms. Now, for B, it wants to know the current flowing through the system. Now, it doesn't really matter which point you pick to calculate current in a series circuit, because if the current starts and travels via the external circuit, it's only got one path, so the current that flows through one resistor is the current that flows through the other. What'll be different is the voltage across each resistor. So in this case, the current flowing through the entire circuit is equal to the voltage divided by the total resistance. And so it'll be 3 volts divided by 30 ohms. And the units do work out to amps, which is the unit of current. Remember, ohms are units of resistance, volts are units of voltage, and amps are units of current. Regardless, you get 0.1 amps. And that would be the current flowing through the entire circuit, as well as the 28 ohm resistor, since there's only one path for current. Now, what's the voltage? What's going to be a little different is the voltage going across the 20 ohm resistor, because it'll be different than this voltage. These two voltages should add up to be the 3 volts. But regardless, you're going to use Ohm's law again. But now I want the voltage, so voltage is equal to IR. Now that we know the current flowing through the circuit, we get 0.1 amps times, in this case, the 28 ohm resistor. So just the 28 ohm resistor will see a voltage drop across that resistor. That's proportional to the resistance compared to the total resistance of the circuit. So 0.1 times 28 will be 2.8 volts. And so it will drop 2.8 volts as you pass through the first one, and then the remaining 0.2 as you pass the internal resistance of the battery. And you find that once you put a load in it, the voltage always drops. Okay, let's look at a circuit in parallel then. In this case, we got two 10 ohm, these are 10 ohm resistances with a 6 volt battery. And in this particular case, you've got to figure out the total resistance in the battery. But for a parallel circuit, which is what this is, you've got branches. So you've got 1 over the resistance parallel is equal to 1 over resistance 1 plus 1 over resistance 2, which would be 1 over 10 ohms plus 1 over 10 ohms, since both resistors are 10 ohms, which means you'll get 2 over 10 ohms, or 1 over 5 ohms, which means my parallel resistance would be 5 ohms. Now, for part B, We want to know the current flowing around the loop. That is the total current. So the current is, again, apply Ohm's law. It's going to be the voltage divided by the resistance. We said it's a 6-volt battery, so 6 volts divided by the total resistance in the cell, 5 ohms, will give you 1.2 amps. That's the entire circuit. The difference between a series and parallel circuit is the voltage is the same, but the current splits up. So the current will travel and then split here and continue here and continue on around and down here and then join back up to come back to the battery. But you get a splitting of the current, since in this case you've got a 10 ohm resistor both ways. The pathway is equally likely, so the current splits evenly. So you should get half of that, or 0.6 amps, but let's do the math. So the current is going to equal the change in the voltage divided by the resistance, or 6 volts divided by 10 ohms, or just like we said, 0.6 amps for each branch of the parallel circuit, for a total of 1.2 amps for the entire circuit. All right, this has been a brief tutorial on circuits, series and parallel, including Ohm's law.